So thanks everyone. We're very happy today to have Gino join us. So Gino is he's a founder and president of AeroNet, who's also one of our 60 GHz cnWave trial customers. And together with me, Antony Holmes from our engineering team, we'd like to share with you the field trial we have done on 60 GHz cnWave. So before we do that, we want to do a quick overview about what the 60 GHz is, what applications, and then we can go through the details for the field. So what is the cnWave 60 GHz is a new product we just announced last month, and we will start shipping the radios next month. The radio is based on 11AY standard. We have 3 platforms we're going to release. The distribution node V5000. This will be used to form the mesh layer with other DN. In addition, the radio also used as access point to connect with CN node for a point-to-multipoint configuration. On the CN side, we have 2 models. One is a mid-gain client node V1000. The other one is a high-gain client node V3000. So the mid-gain is for medium range. Normally we talk about 200 meters. And the V3000 long range, we can support up to 500 meters. Of course, depends on the link availability, throughput, RAN rate you're in. The radio, as we said, is 11AY standard based with mesh support, although it is also Terragraph certified. The DN V5000 has 2 sectors. We can support up to 15 gigabits when we have channel bonding enabled. It's a 2-sector radio with 280-degree coverage. So it's very simple. It gives a very simple installation. We expect all the radios, every pole will have a radio. So when the data transfer between sector to sector, you do not need any external device. All 3 radios support beamforming for both uplink and downlink. So the alignment becomes very simple in 60 GHz deployment. With mesh, we can do the auto expansion, auto healing in the case of a radio failure or a path loss or path job. The data will be rerouted with the mesh network. We're using OpenRT protocol in our mesh technology. All radio are software defined. Common hardware, we can support point-to-point, point-to-multipoint with mesh. On top of that, we have cnMaestro as our NMS. It's a single panel NMS, which not only manage our 60 GHz, it also manage our Wi-Fi 6 and CN Pilot product from Cambium and backhaul product from us as well. So you have a single panel you can monitor end-to-end to see the network performance and also ease for the troubleshooting. For the configuration-wise, we can support point-to-point. So basically, you can do a rooftop connectivity for the campus connection. We can also do the point-to-multipoint to serve a community or do an enterprise coverage. When you extend this point-to-point with more nodes there, you can form a mesh. So because 60 GHz is for relatively short distance, high density, and must be line of sight, with mesh, we can extend the network and grow the network, and also we can overcome obstruction to do a better coverage. More than that, 60 GHz using because we're using the V band with 2.16 GHz channel, we can deliver multi-gigabit throughput. It's also an ideal solution for small cell backhaul. So when we do the small cell backhaul, we can do dedicated point-to-point, which offers close to 1.9 gig in each direction. We can also do point-to-multipoint with a V5000 either as a hosting site or as a relay site to provide cellular backhaul for 5G. When we look at the deployment, we see this 60 GHz can be deployed in the city or in the suburban area. We can also cover the high density in the rural area, like the village center, where we can offset the traffic from the like 5 gigahertz or CBRS band coverage. So 60 gigahertz really solved for high capacity, high density solution. We can using 60 gigahertz for Wi-Fi backhaul. We can also using 60 gigahertz to provide backhaul for smart city, the video surveillance cameras. We can also using 60 gigahertz just to provide fixed wireless access as an alternate solution compared with fiber or cable solution, because we can deliver true gigabit solution. Not only that, 60 gigahertz also offers symmetric throughput, which is even better compared with cable or fiber when they have more downlink and less uplink. With current pandemic, most people working remotely and kids study to the online course, the uplink capacity is a challenge, and 60 gig is really with the symmetric throughput for both uplink and downlink. With the true gigabits, this really bring a advantage over fiber and cable as well. On top of that, as we said earlier, we have this cnMaestro, be our common network management for the whole network. So today we have more than 15 customers with cnWave deployed. We have many customers in North America, both in Canada, in the United States, in Puerto Rico, and we also have multiple trials in Europe, in Africa, and on down to APAC and Australia. So from the picture you can see here, let me bring my pen here. So this is a deployment in Alaska. We have the this is a V5. Actually, this radio is a V5000 radio as a host in the city, and then we're shooting for the client node down the in this direction and this direction, those areas. This is showing a deployment in York, UK. This one is serving a cafe shop. Actually, the radio is provide the high-speed fixed wireless for them. And this is one of the V1000 deployment in UK, and radio is mounting for a light pole and provide the connectivity for the Wi-Fi backhaul. We have picture here. This is deployment in Asia. Actually, this one is in Malaysia, and we're forming a mesh network with 4 DNs from a mesh, and doing this will be using for fixed wireless access and also the outdoor Wi-Fi backhaul. This application. The picture showing a V3000 deployed in the rooftop. This is the deployment in Australia. And this is also for a multi-point configuration to provide fixed wireless access for the deployment. This is another one. This is V3000. This is the V3000 deployment. I believe this is in Puerto Rico. Actually, Gino will share more details about his deployment. And this one is one of the Asia deployment as well. You can see the V3000 installed here for a mesh network. Is one of the earliest deployment we had in our UK office. We have the V3000 shooting for a long-range point-to-point link, and also we have our V5000 form the mesh to cover our office area. And shown here is one of the test result. You can see this one is a multi-point deployment during the test. This is with NextLink. We had a news published last week, and you can see the uplink throughput is about 1.8 gig, and downlink is 1.8, and uplink is 1.8 gig as well for a multi-point deployment with V5000. So from our first trial to now, I think it's over 5 months already deployed, and we have more customers deployed the network in the last 3 months. Some of them has been for a longer time. Some of them has been running for about a month. the, the performance is quite encouraging, and we're going to share more details after in the following slides. So at this moment, I want to run a poll to get some input from our audience. So, okay, so launch this poll. So the poll will start. Poll. I have the poll ready. So if you can look at the technology we offered here and let us know what your choice is. We're gonna wait for another 30 seconds for the poll. Because currently I see a lot of interest for 60 gigahertz fiber. There are some interest for 6 gigahertz. There's some interest for cable as well. So if you haven't voted, please vote. Let's see, last 10 seconds. Okay, I'm gonna close the poll. The result is, the question is, if you plan to offer multi-gigabits solution, connectivity, how you plan to deploy. And we have 85% people saying it will be 60 gigahertz. We have 8% saying it will be fixed wireless with 5G, the 24 to 39 gigahertz. We have 13% answer is using 6 gigahertz fixed wireless access. There's 49% will be fiber, and 8% will be cable. So I think seems like a majority will be a mix between wireless and fiber. So on the wireless side, actually majority will be on the 60 gigahertz. I think one of the benefit is 60 gigahertz is an unlicensed band. So that is one of the advantage compared with 24 to 39 gigahertz. So that's the poll result. So let's move on. Okay, let's move on. Next page. So during the field trial, we want to verify a few things because one of the thing is a lot of network is IPv4. So during the trial, we're testing both IPv6 and IPv4. The Terragraph or the mesh support fundamentally is based on IPv6. So if you look at the left side, this is a network with, let's say, a pure IPv6 network. When customer has this thing, so they're using the IPv6 network, the internet, and then they're using the cnWave at the pop side because we're doing the IPv6 on the fundamental design, so IPv6. And when they're using the end-to-end controller also using connect with the cnWave network, the deep pop side. And the only thing between end-to-end controller within Maestro, we're using IPv4. That's like a deployment in the IPv6 network environment. When we moved IPv4, we do not need any external device. Instead, we're running layer 2 bridge tunneling over on top of the IPv6 to deliver the IPv4. So when we do that one, you can see is, you have exact IPv4 network. You can connect to the DN pop site. From the pop site, we're gonna enable layer 2 tunneling on our cnWave product. So we'll build a layer 2 bridge, basically carry the IPv4 data over the IPv6. And then we will pass IPv4 data from the DN or the CN to the CPE. So with this configuration, within the cnWave radio, we do not need any external converter or switch device to IPv4. The only part you will see from customer side, you will see IPv4 data be the end-to-end control to the pop side. But we also support onboard end-to-end controller. In theory, move the IP, you can you can enable the onboard end-to-end controller. When the end-to-end controller is on board with PopSite, then you don't see there. So then from the user, everything IPv4, even for the management part. So the whole thing will be much simple for the customer to deploy. When we do the point-to-point, it's even simpler than that. It's, you can do IPv4 or IPv6. Everything is very naturally. So we have the both configuration. It's ready to make customer much easier to do. One thing we want to work in the field. So when we had, I'm gonna go with different deployment. This is a point-to-point link. So the point-to-point link is deployed. Actually, this one started in May, and we have a radio deployed installed on nearby the office site in a remote stand, and the link is about 1.2 kilometers. And here is some screenshot where based on the monitor. I think one of the key concern is how the link responds for rain. And you can see here, you can see the radio works on the top modulation. This is the MCS12 modulation on top mode. This is uplink throughput. This is downlink throughput. This is the uplink throughput. And when there is a rain, then you can see the rate. This is the rain rate millimeters per. This is rain rate per minute. When the rain came in, when there is small rain, very small rain, there is no really impact for the modulation change. When the rain starts kicking more, then the ACM, the adaptive coding modulation will kick in. It will be going to a lower modulation. We'll be down to here. Actually, this one goes to MCS7, and it will, depend on rain rate. In this case, actually the rain rate, this is about 24 millimeters per hour rain rate at this moment. So you can see when the rain come in, the link will respond. The modulation will respond. When you have very heavy rain, like we saw in our data we captured, when we have at the moment when we have over 100 millimeters rain rate, the link will drop. So it's not saying the link is not sensitive for the rain. It is sensitive, but depends on your design, depend on the fade margin you put in there. You can the link will survive for the light rain or when the rain is not very heavy, but in the heavy rain situation, the link will drop. We do have a future feature will be introduced for 5 gigahertz fallback. So with our V3000, we have an accelerate port. We can connect with a 5 gigahertz radio to do the failover using the 5 gigahertz. It is not supported today, but that's one of the features we will support in the future. So this is kind of like you can see the point-to-point link deployment. And this is one of the multi-point we had. The installation is we have the fiber tower, this water tower, and then we have the DN here, and we're covering community with some of the existing customers they have, and we choose the in the early trial 2 customers, and one for a longer range, one for a medium range. The longer one is about 300 meters range. One is about actually less than, I think it's about 170, 180 meters distance for the short one. And during the test, we can see about, during the normal operation, we can see it's both of them running on the top mode. We have about 1.8 gig for both uplink and downlink direction. And this is another deployment. This is in the middle of Europe, and similar thing. We have inside here with 2 links. We put them into the same sector. One is a longer range over 250 meters range, and it's short range about 80 meters range, and in this in this connection we have the CN1 is long range into the short range, and I put their test report. Basically, you have they run the UDP test. They also run a TCP test for downlink only, uplink on both. So you can see the sort here for the this is the longer range. This is running on MCS 10, sorry, MCS 8 in this one, and this one is running MCS 12, which is the top modulation mode. So on the UDP section, you can see it's close to 1.9 for downlink, 1.9. On the TCP, it's 1.8, it's 1.5. Run the both direction. In this case, is UDP is about 1.8, and this one is about a gig. Aggregate is a gig. Downlink a little bit more. And it's 1.2. The uplink is about 850 meg. When this is also run a result for the downlink with being 1 and 2 running simultaneously, and you can see the so I put the throughput for each of them together. You can see that right now UDP is about 1.9. This actually is even higher. This is 2.9. 2 is 2.9 gigabits, almost 3 gig. We run the both direction. We have the about 1.7 gig for downlink, uplink, and 2.7 gig for downlink. And we have the UDP session as well. This is the downlink only, uplink only, and both direction. So this is the test report in multiple in this deployment. Moving on, we have a mesh deployment. This is the one of the site we deployed in Asia. So here we form a simple mesh. The longest link is about 190 meters with, and the shortest one is about 80 meters. This trial actually, the link between, you can see there's the pop site here. There is the this is the one of the pack site, NOC 1, SOC 2 site, and the link of this between the pop site to the pack 1 and NOC to the pack site, the link is not completely clean line of sight because there are some tree. The folio casts some not clear line of sight, which is not really ideal for us. We like to see in practice, we want every link to be clearly line of sight, because 60 gigahertz is not ready for to penetrate any not line of sight or near line of sight. But in this deployment, it's not completely clean. And so the throughput is not on the top as we expected. And this is not like the throughput and latency we tested. This one shows the basically those 4 links here. You can see the throughput. This is about 800 meg, and latency average is about 0.6 milliseconds, and this one is close to 1 gig throughput. The latency similar thing, and this one is the shortest link there, showing 1.2 gig throughput with 0.7 milliseconds latency, and this one is also about a 1 gig with 1.2 microsecond latency. So this is the mesh deployment we have. As I said, the link is not, the RF condition is not ideal because the 60 gig is ready. We require line of sight. So this is the testing. The purpose of this this customer, or the ultimate deployment of this customer, is a citywide deployment. And the radio. So this is the design we work with the customer for this design. So you can see one of the main purpose for the network is to provide fixed wireless access for over 100 customer, small business, like restaurant, some small business, um, city here. It's a area of the city, and most of the radio was deployed on the light pole, using the existing light pole there, for about 8 meters high. We do have some DN we're using in the on the top of the rooftop for the local business there. So it's a mix about light pole and rooftop. On top of that, we have a few fiber location we're using. Like this is one of the fiber location we have, and this is another fiber location we have. To serve the whole area. In addition to fixed wireless access, we also provide also use for outdoor Wi-Fi coverage. So you can see is when we have the DN, actually, because DN is on the light pole, off there we can connect with the outdoor Wi-Fi device. Our DN V5000 has the auxiliary port with PoE out, so we can also from there to power the camera, which simplifies the cable connection and makes the whole thing much clean and easy during the installation. Also be used for other purpose for backhaul, such as cameras as well. So the city, you can see with the saying we form along the street. We also form different runs with mesh to get more alternative route to improve the network availability. In the case of link failure or device failure, we can basically have the data rerouted. The good thing about that one is the mesh is the network is a live network. Like when we foresee zero business here in the future, we also foresee or the operator foresee the business eventually in here. So the network, and we didn't know that today, but when we need it, we can extend from here, or then build the site in here, close the coverage for this area. And when we do that, we don't need to change or manually change the network topology or routing, because the routing is a live routing. It will change automatically. So this is kind of the mesh one we have. So move to next. I want to pass to Gino. So Gino can give us from a customer side how he deploys cnWave in his network. So Gino, it's your turn.
Thank you very much, Alan. And good morning to everyone that's here in this presentation. We would like to share our experience with both Terragraph and Cambium Networks cnWave product. A little bit about AeroNet. We were founded in 2001 as a wireless ISP. We then transitioned to integrate fiber in our network, and as of today, we're about 80% fixed wireless and 20% fiber. We cover the markets of Puerto Rico, USVI, and South Florida now. And our main market or segments that we cater to is the enterprise, small business, and wholesale. And we have a small residential footprint, but I will say over 65% of our end user base are within the enterprise, SMB, and wholesale markets. We are the only ISP in Puerto Rico to be included in Inc. 5000, and we were named WISPA's ISP of the Year in 2012, and we received the Triumph Award in 2018 after our recovery from Hurricane Maria. We do also have licensed spectrum assets in the 2.5 and 3.5 bands. So hopefully that will give you an overview of our operation. Next slide, please. So Terragraph. We became interested in Terragraph technology back in 2016. When Facebook announced it, they announced they were working on several connectivity initiatives, one being a mesh 60 gigahertz base, let's say, product. And we thought that was a pretty great idea, and we became interested pretty fast and reached out to the Facebook connectivity group to see if we can some way join them as a partner for trying the technology. That took about maybe 3 years to get together and be able to actually be part of a trial of Terragraph. So I want to thank the Facebook connectivity group for that opportunity. We began discussions of the trial last year in the mid-summer of 2019, and we defined a specific area here in Puerto Rico, the capital city of San Juan. We have an area which is called Old San Juan, which is historic city, is about over 500 years old. So you might imagine it has its challenges with infrastructure. One of them being the fiber is pretty limited in that area. And the only solution is fixed wireless, because you cannot trench the streets or basically do a lot that will affect the aesthetic of the city. So we thought that was a great area to try out Terragraph, because the infrastructure in the old San Juan city was not up to par with the needs of the population. So we engaged with Facebook. We defined 14 nodes. Those 14 nodes were composed of DNs. Some nodes have 2, 3, or even 4 DNs. Because we used the Facebook hardware. Facebook developed the hardware that you're seeing here in the picture for their trials, and the coverage per antenna is about 60 to 70 degrees. So it's not similar to Cambium's new design, which I think is better. Overall, we have about 50 total units between the distribution nodes and the customer nodes, and we were able to deploy all the equipment in about 4 weeks. And for this trial, we didn't use city infrastructure like poles. We decided to go with the private route with signing up private partners, because we thought and we knew it was going to be a faster deployment. Involving the government will take a lot of permits, and will have been a delay on the trial. So we went with private partners and used rooftops as the nodes for the trial. We thought about Terragraph because obviously millimeter wave, having bigger channels, will allow us to provide us higher speeds. The time to market versus products like fiber will be extremely different. Case being, deploying fiber, even if it's aerial or trench, takes a lot of time to get the permits going, and then the rollout and the installations. With fixed wireless and the experience we had for about 19 years of deploying fixed wireless, we knew that it was the ideal solution. And obviously, the cost effectiveness of the solution versus fiber. Also, added bonus, you will get an increased resilience of your network. We get the mesh protocol that Facebook integrated in the platform, and the unlicensed spectrum will allow us to have a quick to deploy and cost-effective solution. So this trial has been running for a year now on Old San Juan. We have still several customers connected to it, and they're all pretty happy with it. We have a great experience with the trial. I can share more details offline if you like. But as defined by Facebook, their Terragraph product was just a technology demonstrator. They did not in any way intended to go to market with a product, so they reach out and identify partners like Cambium, so they can develop the actual products that the service providers can use, and that's the case of us. So as of today, this equipment will be eventually changed with cnWave equipment, and the deployment in the old city will be expanded accordingly to the needs of the whole area. Next slide, please. This is a map of old San Juan and the mesh network that we deployed. Here are the 14 nodes. As you can see, it's some mesh design and have some inter-node interconnections to maintain the mesh in case of hardware failure or rain fade. Here in Puerto Rico, we are within rain zone N, sorry. So we do experience a lot of rain, and the mesh designs helps us to overcome some fading events in the network. The whole mesh system was fed by 2 points. They're kind of highlighted here with the clouds. One is fed by fiber, a 10 gig fiber, and the other node is fed by a 10 gig point-to-point E-band link. Next slide, please. So cnWave, as soon as I knew about Cambium's 6 gigahertz Terragraph product, I started to let's say call a lot of people within the Cambium network for us to be able to trial the product. We were very interested in obviously trying this new product that will take us to the next step, and we thought that we will be able to provide them with our feedback based on our Terragraph experience. So we did receive a V3000 point-to-point link that we installed between 2 of our facilities, one being our main place of business and our warehouse. The link is 660 meters long, and it's, as you can see in the picture, this is one of the units that we installed. And our feedback from our installers has been pretty good. They tell us that the hardware is all designed and pretty sturdy and it's easy installation. Obviously, it uses a standard PoE, although you can use also fiber. We on this test trial, we use regular shielded outdoor Cat5, and the techs needed a scope to fine-tune the alignment of the 3000 units. Some of our feedback is that some sort of alignment tone or app will help for the alignment, and that's a takeaway for Cambium to better the product. Next slide, please. Okay, on the performance side, here's basically an output from the GUI of the link. As you can see, it's just under 60 meters, and the units have a built-in GPS, so that the map is auto-populated by the GPS. We ran our test between 2 MikroTik RB4000 units connected on the SFP Plus port. So they're basically negotiating at 10 gig. And from our tests, we were able to pull about 1.7 gigabits of traffic one-way TCP. And then when we did the symmetrical test, our test yielded 1.25 gigabits symmetric in TCP2. So our results are a little bit different from the ones that Alan demonstrated, and that's something that we're researching into to see how we can enhance the performance of the link. The latency stayed between 1 and 2 milliseconds through all the tests. Next slide, please. So the way that we are evaluating deployment of the cnWave is obviously traditional point-to-point scenarios where we can use it for high capacity customers. We can use it for backbone and other scenarios. The multi-point mesh, which is basically where the cnWave shines, and the multi-point to multi-point all mesh, that's kind of if when you use the actual customer sites as part of your mesh. So you can add, instead of using a CN unit, you can use a DN on your customer site and extend your network in that area. So that's another model that we're looking at. And then there's some other different scenarios that we also are looking for some local partners so we could do some trials. One being industrial indoor use of the equipment on large spaces and warehouse where they need fast connectivity within the facilities. And the other is kind of a little bit creative idea that we had here, residential indoor. That being, we deploy a lot of solutions in MDUs, and sometimes we find that some old MDUs have very bad conduit. So pulling fiber or Cat factor is pretty difficult, sometimes impossible. So we thought of maybe putting one DN per floor and having the CNs on outside of the residential apartment units facing down the hallway and connecting providing them internet. So that's kind of a nice idea that we will try out pretty soon. I'll let you guys know how that goes. Next slide, please. So we're pretty excited about our partnership with Cambium and Terragraph. We've been in Cambium shop for 19 years now, so we are very excited that this new tool engages with CN Ministro, the Link Planner, and possibly CN Heat in the future. The Cambium, as you all know, have a tested track record, and the ease of use and convergence between all the platforms is a big sell for us, a big plus. And Cambium has been pretty open to feedback and suggestions during this trial, so we're pretty happy about that, taking our input. For us, at least, our next steps will be to do a multiple trial. We're expecting the hardware to arrive anytime now, and we'll keep you guys posted on that one. Identifying the symmetrical speed issue that we saw on our trials and have a resolution for that. Maybe it's some sort of alignment, some firmware update that we need to do, so that we will take care of that pretty soon. And start our field deployments. We're very excited to receive mass amounts of equipment and start to deploy like now. So I will like to thank the Cambium team for allowing me to be here, and any questions that you guys have, I'll be pretty happy to answer them later during the seminar. So thank you, and back to you, Alan.
Sure, thank you, Gino. I think we're gonna end up to this final slides we have here. So from us, 60 gigahertz is really a revolution solution to on the wireless technology to provide 2 gigabits. One of the key things we want to focus is to deliver the lower total cost of ownership. Our V5000 design is very unique with 280-degree coverage, so we do not need any site routers to pass the data between sectors. And more than that, as Gino mentioned, one of the key things when we do the fixed wireless access coverage thing is using the mesh. Not only mesh give us more coverage, but also mesh give us redundancy for the network. With the mesh, you're gonna see a lot of overlap between the sectors because the DN need to talk with DN. And with our 280-degree, we can provide a quite cost balance for the efficiency, for the coverage and the cost. In addition, we have two different models for client node, the V1000 for mid-range and the V3000 for long range, so we can meet different requirements. Beamforming for easy alignment. So this really makes the whole thing, the overall cost, network design, and the deployment cost go low. The V3000 is with the beamforming support very long range, but also multi-gig throughput. So this is really could be a solution for fiber extension or dedicated links for your enterprise deployment, or even the DN to DN make the extension there. Already hardware ready for channel bonding. So today in release 1, we're not supporting channel bonding, but hardware is ready. With simply a firmware upgrade next year, we will be able to double the capacity with existing hardware. Outdoor radiate for the radio. The each DN support up to 30 devices for the high density deployment. Same Mastro, which is a super important thing for from Cambium to offer the connectivity or the kind of make our solution under one management. So this is again, it will help you to have a true end-to-end view for your network. Last piece is we're offering the network planning tool and the link planning tool for easy planning for both your simple network for point-to-point or point-to-point. We can also provide planning for the mesh solution. So that's a solution from us on Cambium. So next, before we jump to the Q&A session, I'm gonna start another poll. So if you can provide your feedback. So the poll start. If you can spend a few time in the last 30-40 seconds, and then we will jump into Q&A session. If you do have some questions, can you please enter your question so we can go through that in the rest of the time. So we have another 15 seconds. We're gonna ask people to vote. It's a multiple choice. You can actually it should be a single choice. Depend on how quickly you wanna deploy the cnWave or 60 GHz technology. All right, last 10 seconds. Okay, so the question is, when do you plan to deploy 60 gigahertz? The 33% saying it will be they're planning for the next 0 to 3 months. We have 25% will deploy in 3 to 6 months. 20% will be 6 to 12 months. 13% said they already have 60 gigahertz deployed, and we have the rest 10% will be looking for 1 year from now. So that kind of like the feedback. So if we're saying it's about 58% will be deployed in the next 6 months. So it's quite encouraging. Thank you. So with that, let's jump into the Q&A session. So if you have any questions, you can ask to either we have Antony Holmes here. We also have Gino can answer all questions. So let's go through the questions. The first question is, do you have any experience yet with snow collecting on the V3000 reflector? So Antony, you wanna, oh, you already answered this one. You wanna speak for this one or?
Well, just very briefly, we have asked, people have asked this question not only about snow, but water as well. And when we modeled this, we actually were very careful of, would that be the case? And especially the position of the arm as well for the reflector. And we were also concerned about that. So our modeling shows it doesn't affect this, although you can use a hydrophobic spray. We recommend this in snow regions, even on plastic radomes, if you want to avoid ice and snow collecting.
Okay, next question I have is about IPv4 support. People is asking, is this done by SRv6 or the GRE tunneling? Can you share a little bit more about IPv4 support?
So quickly, I mean, I did answer it. SRv6 will not work in this situation. I know people may have thought SRv6 was an option, but actually when you're trying to tunnel through a mesh, you end up only being able to support one tunnel and the policies don't work. SRv6 is a great way of using VPP and being able to put policies on traffic flows, but not tunneling. VXLANs would be another option. And Cambium will be looking at that in the future to speed up support, and especially when we do channel bonding, we have to support more packets per second and over 7 gigabits per second.
Right. Next question I have is people asking, what's the maximum distance between DN and CN?
So I think it really does depend on range region you're in, what availability you want. This is why Cambium bought out 2 different CNs. We bought out a long range one, we bought out a short range one. Link Planner is your friend here. It is supported in the latest Link Planner. You can see the difference in there for your region down to 30 meters as far as rain availability is concerned. So yeah, take a look at Link Planner for these because it will vary. I've put a little bit of detail in there of what you can expect.
Thank you. So I will go to the next question. Has compatibility been confirmed with any other Terragraph certified vendors?
So trying to get hold of any other Terragraph certified vendors' equipment at the moment is now impossible. Gino knows how hard it is to get ours, but no, we are shipping these. We have done our certification testing and our interop testing using Facebook's original equipment. We are actually deploying our equipment in areas where the Facebook equipment already is and interoperating with the network management system. So we are certified and we do plan to stick with that certification.
Right. I think in addition, just a comment here, the certification is we're gonna certify it with the Terragraph, but also I think it's every OEM partners, they're supposed to do their own certification with Terragraph. And this is just like I think like the MEF certification thing. If you're all certified on same level, then it means you will be interoperable. Is that correct? Okay, next question I have is okay, the question is, I have a customer who need 400 meg real throughput. My customer's building is right in front of my building, less than 350 meters. Will this be good? Will this be a good solution? What about rain? So Gino, you want to answer this one?
Yeah, 350 feet shouldn't be an issue with rain, and 60 gig will be a beautiful solution for this.
I mean, Puerto Rico has a lot of rain, so if Gino said it works, it works.
Yeah.
So let's move on. Next one. Okay, another question for Gino. In a coastal saltwater location, what has your experience with cnWave been regarding corrosion so far?
Well, the equipment, we have the equipment on hand for a short time. It's been like a couple of months now, so I think it's too soon to tell. But based on our experience with other Cambium equipment, the equipment has been able to withstand the local environment pretty well. So we have radius on the field that some have like 10 years. So I will say that at least on the Cambium side, their product quality and manufacturing capability will basically withstand all you throw at them.
Okay. So another question actually one more question for Antony. Where we stand for regulatory approval, FCC and ETSI?
So yeah, basically all tests are complete, all reports are written. ETSI was in fact signed off today, so we're ready to ship ETSI. As far as FCC is concerned, it's with the TCB. As people may know, that is a review and the grant will be issued. And we expect all this to happen before the end of next week.
Thank you. So question for Gino. Can you give any color on the cost saving for Cambium product versus fiber?
Yeah, you have two flavors of fiber, one being trench, which is pretty expensive, and the other aerial, which is less expensive. But even at that, our numbers indicate that we will have doing cnWave will be like about 60 to 70% less expensive than running aerial fiber on the neighborhood. So that obviously that's going to depend on the density of the area, how many residents, but that's a pretty good range for us. Your mileage may vary on your environment, but that's our numbers.
Mm-hmm. So Antony, question: why you designed, what is the reason behind the two-sector design of V5000? Is mesh support from day one?
Okay, so we looked at this about a year ago. We were on the idea of, oh, let's have 90-degree sectors. And then we modeled this, we put it on a lamppost. We had 4 of them on a lamppost covering 360 degrees. Basically, it was a complete nightmare. The amount of power it took, the space it took, the switching between them, and potentially the different models you might have to have with a switch, without a switch, power modules, etc. It was just too big and bulky. So we looked at what is the most cost-effective solution, small package that can do everything that we really want to do with a DN, and that's have quite a wide coverage area and be able to support a dense population of CNs. And that's why with the V5000, we're able to cover that 280 degrees, and the blank space behind the pole, and then be able to support 30 CNs off that. Now, given the radius that you're looking at of the V1000 having, say, 200, 250 meters, and the V3000 going up to 400 meters, say 500 meters, you know, that sort of radius was a nice compromise, and supporting that many CNs. So that's why we have 2 radios in there, to be able to cover that 280 degrees in a single package.
Thank you. So question for Gino, are the CN typically mounted on the rooftop or windows?
We mount it on the rooftop. For us, it's easier type of deployment than Windows.
Right. So I think, I mean, from some of our trials, I think it really depends on who you're serving. If you're on the city, if it's a DN on street level, we do have some customers, they have the CN mounted, you know, on the wall. But in other area, I think it's really depends on the real situation. We support both wall mount and the roof mount, pole mount on the top of the roof. It's really on the, I think it's what kind of situation or where you install the radios. Nothing block us or prevent us to do that installation. Next question I have for Antony is, do you plan to add auxiliary port on V1000 to power cameras?
Question. So yeah, so on initial release, we chose two CNs to roll out with. A high end does, you know, it's a great point-to-point device, great long-range device with an aux port on there with the V3000. The 1000 is meant to be the residential unit, small, sleek, you know, fits in the palm of your hand, very easy to install. We do have options to fill out the portfolio. As you can see with many of our products like EPMP, 450, you know, we will have a roadmap and deliver different options. A compromise between a V3000 and V1000, for example.
Thank you. So Gino, one question for you is: do you see any experience? Do you see any interference between your 5 gigahertz with 60 gigahertz?
No, not at all. Zero.
Okay, thank you. A question for Antony. Is there any performance or processing impact with doing IPv4 and enabling tunneling in the nodes?
What we're finding is even at these data rates we're getting at 3.6 gigabits per second, we are not seeing a performance impact. Especially with large packets. Obviously, the smaller packets you get, you might, but we're not seeing that the difference between IPv4 and IPv6.
Mm-hmm. Thank you. Another question is, what is the design life cycle or for the V5000 life expectation of V5000 radios?
As long as people keep buying it. I don't know. As you know, with most of Cambium's products, longevity is actually designed into these. A lot of effort goes into the mechanical design to make sure they perform over wide temperatures in different environments and for a long time. So we expect this to be around for quite some time. As I say, I think it's a great combination of features and functionality in one neat package.
Right. So there's some question regarding V1000. Can V1000 be used for point-to-point?
Yes, it can. It can be used as point-to-point. It's not obviously as powerful as the V3000, but we've had speeds out of that edging up to about 1.8 gigabits per second bidirectional. But yes, it can be used as point-to-point.
Is this available in day one? Using a tool of V1000 for a point-to-point link.
That's a question for you, isn't it, Alan?
Yeah, I know the answer. You answer the question. Okay, so it's not available in day one. So at day one, when you're using V1000, you can use this one with V5000 for a point-to-point. We will support point-to-point configuration with V1000 to form a short distance, like a bridge in the box concept. It will be available in the next release coming in Q1 2021. But currently, at the very beginning of the first release, this is the only point-to-point configuration we will not support out of the door on V1000. Okay, maybe this is a question for Gino. So the question is, the question is they're asking is, if a unit is stolen, is there any unencrypted data stored in flash? I think the question for Gino is really is, do you experience the kind of thing, worry about unit to be stolen? From user point of view, what do you see? Is this something you worry about? You expect something to be done in the product side?
We haven't experienced any theft or equipment in our network. We have experienced stolen batteries and generators, but not radios. So that's something actually we haven't thought about that, but it's a good point. But I don't know if any information gets stored in the flash. That's above my pay grade.
So Antony, do you know anything we save any unencrypted data in the flash? Maybe if radio is lost, will compromise the network?
There are certificates in the radios, but in order to access the radio, you are going to need to know what those certificates are and get those. So if you strip it apart and are able to read the flash, but it is encrypted.
Thank you. So any recommendation for the routers? I think it's Wi-Fi routers in case of the end user, using 60 gigahertz. The R195 series seems to have many limitations. Is there an improved router expected soon, or should we consider third-party vendors? So I want to, Antony and Gino, can you both address this question? So Antony, start with you first.
So in-house routers, we actually have been, my experience at the moment is we're actually playing with Wi-Fi 6 devices. So we're using the VX2-2s. So I know it's a different range compared to the R195. The actual R195 though is, you will see some software upgrades coming very soon, which will bridge those limitations that you may feel you have. But yeah, actually, this solution works very well with Wi-Fi 6.
So Gino, you want to address this one as well?
Well, I think that you have to find the right tool for the customer problem to solve it. We do use Cambium Networks and pilots on some environments, and we do use other equipment on other solutions based on what the customer is expecting. If the customer is expecting anything to receive about 1 gig via Wi-Fi, then you need to look at Wi-Fi 6 solutions. So being that Cambium or whatever other manufacturers that you like or think that will fit your need.
Yep, thank you. Let's just add a little bit more. The Wi-Fi 6 really offer the gigabit throughput from a router point of view, and we don't want backhaul become a bottleneck to give customers the experience they really capable. So 60 gigahertz with the gigabit backhaul for the Wi-Fi, that is one of the main reasons why this is really needed, because no matter the indoor outdoor Wi-Fi, when you have a Wi-Fi 6 equipment capable for multi-gig, you don't want your backhaul become a bottleneck to limit the throughput for the radios. So move on. This is a question about roadmap. I will try to address this. So the question is about, what is there any more models will come out in 2021, and people saying something in between V1000 or V3000 for a little bit longer range, but not as big as the V3000, the V3000 models. The answer is yes. We do have many different ideas of the variations we will introduce in 2021. And some of them will be filed to that part, and we will share more details when the product coming when we're ready to release. But yes, this is not we're not limited for those 3 models. We have more models will be released in 2021. There are questions about the pricing, so please check with either our distributors or channel partner resellers. You will get the price for V5000, and we have all the channels has orders to us already, and they will get the radio in November and December. So if you are looking for deployment or you want to touch the radio, please contact our channel partners. They will be able to provide the answer for the price information. We're running a little bit late. We're already 10 minutes more than we expected. We still have many questions not addressed yet. So I will address one more question, then we will close today's webinar. We will answer all questions and we will post the answer in our webpage after the webinar. So if some questions not answered, please just follow up with us. You should see the answers. So let me pick up one from all the things listed here. Okay, let's. So the question is, how is the provision? How to provision the radio? Can I pre-configure radios in the warehouse, or it require engineers to do it on site? So Antony, you want to address this one?
Say that again, Alan. I was answering questions.
Oh, I'm sorry. So question is how the provision works in cnWave product. Should we pre-configure the radio in the warehouse, or it does require engineers do it on site?
So the way the provision works is it is centrally controlled. Most of the configuration is centrally controlled by the end-to-end controller. You will set up the link that you want to connect up, and basically you then put the unit, attach the unit to power, and then it will find the DN. The DN then routes back to the end-to-end controller, and the end-to-end controller will download the configuration to the unit. So provisioning of this can all be done at a centralized point before it even gets onto the gets out of the door. If you want on site, you can do it on site as well, but centralized control, centralized configuration is the key on this.
Yeah, I think it's really, this makes the whole thing much easier and simple. You don't need to worry about configuration backup either in the case of replace a failure device, because all the configuration is centralized, controlled by the end-to-end controller. With that, we're gonna close today's webinar. Thank you very much, join us, and also thanks Gino to join us to share his experience on cnWave. Thank you all, and we will publish the webinar on our webpage. Thank you.
Thank you.
Thank you very much. Bye-bye.